Today we will discuss 6R PUMA type arm, special arm. PUMA, the full form is Programmable Universal Manipulation Arm. The inverse kinematics of 6R PUMA type arm. This is the geometrical figure. See here, this one is PUMA type. This is shoulder offset. This link, it can rotate this way, this one rotate this way, and this link rotate in horizontal this, and vertical axis is vertical, so it rotate this way. The exact mechanism, see here, this one is 6R PUMA type arm, programmable universal manipulation arm. See, this one is x-axis, this one is y-axis, this one is offset, this link offset having length d1, this one is d1. It can rotate this way from this, so here the axis is vertical, it is called shoulder offset. The other link is this, having length A2, and the third link is this, and we have considered home frame here. X-axis, y-axis and z-axis is coming out of the plane of board. This one, this axis rotate this way, so axis is vertical this way, so this one rotate is like this. But here is also axis of rotation horizontal, here is horizontal. So from this joint can rotate this way, this also rotate this way, but this one is rotate this way from this axis. Now we want to achieve using this PUMA manipulation, universal manipulation arm. Suppose some reachable point P, X, Py, Pz, suppose it is here, Px, Py, Pz, and we want to achieve this end effector frame here. So for this we will rotate this way, because of this line and this point must be coincided the same vertical plane. So suppose the achievable point is Px, Py, Pz here in 3D, X, Y and Z is coming on plane of board table, and we want to achieve this. So first, to align this, we will rotate this from this axis by theta 1, this way, by theta 1. But the point is here. So from this we will rotate this way at an angle theta 2 from this, and elbow up, so this way, and the projection is here. So it is at an angle theta 2, and it is from this line it is theta 3, but from horizontal it is at theta 2 plus theta 3. So projection is this. So this one is A2 cos theta 2. It is cos theta 2. So the projection of this is here, and this one, it is at an angle of theta 2 plus theta 3 from horizon. So projection of this, it is A3 cos of theta 2 plus theta 3. So end effector frame here, this one. Now see the geometry. So ultimately we want to find for this PUMA type arm, what about the angle theta 1, then after theta 2 and then after theta 3. So we can achieve certain point. So if we rotate this way, now it is not this, it is projection of this. So it is A2 cos theta 2, and this one is A3 cos of theta 2 plus theta 3, this one. and the frame is rotated from this to this theta 1, so it is from this axis, this one is theta 1. Suppose this one is r, this one is r, and this one point, it is px, this one is px and this one is py, px and py. So this one is root of, this one is denoted as r, it is root of px square plus py square. So point in 3D is here and the projection of this is here. So it is, this point is has coordinate px comma py comma 0. So this one is r, this one is d1 offset. So this length is root of r square minus d1 square, Pythagoras theorem, because it is 90 degree angle. Root of r square minus d1 square. So it is a2 cos theta 2 and plus a3 cos of theta 2 plus theta 3. It is root of r square minus d1 square. So we want to find three angles. What about this angle? How much rotation we require? And then after to achieve this point, we will rotate this way theta 2 and this way theta 3. So projection of this is px comma py comma pz. But if we project here, so it is px comma py comma 0. So for this, what about theta 1 angle, what about theta 2 and what about theta 3 with this line? But from horizontal line it is theta 2 plus theta 3. So we can achieve this point. But the projection gives px comma py comma 0. So theta 1 from the geometry, suppose I have made dotted line here parallel to this. So it is perfect rectangle. So we have rotated this frame by theta 1 this way. Suppose this one is alpha and this one is phi. So theta 1 plus alpha is phi. This one. Here, so theta, just a minute. See here. Theta 1 is phi minus alpha. But what is phi? Phi from this right angle triangle, phi is py by px. This one is px. So tan phi is py by px. So phi is tan inverse of py by px. So phi is arc tan 2. Here 2 is not multiplier. Because of common tan inverse function has a domain open into minus pi by 2 plus pi by 2. But for this modern robotics, we have extended this domain from minus pi to plus pi. So arc tan 2 we have symbolized this function. So arc tan 2 for py by px, that is py by px. The symbol notation is here, minus alpha. Alpha is what? So this is d1. Tan alpha is d1 upon this. And it is this. So tan alpha is d1 upon root of r square minus d1 square. So theta 1 is phi minus alpha. So arc tan 2 py px minus arc tan 2 d1 comma root of r square minus d1 square. And the second solution is given by, if we rotate pi degree, theta 1 is pi plus arc tan 2 py px, but these coordinate interchanged, rectangle interchanged. But second quadrant, suppose this one is first quadrant. So this is second quadrant, 2D plane. Then it is tan has negative sign and order change. So minus of root of r square minus d1 square comma d1. This is the second solution. Now from the geometry of the figure, see here, we require theta 1 as well as theta 2 and theta 3. What is theta 2? See here, this one is offset d1, this one is link length a2 and this one, this span is a3. So we have rotated this way and this one. Then the projection is here. So this is theta 2. And from this, how much it is at an angle something? Say theta 3. So we want to find theta 3 using the geometry. See here. A2 sin theta 2. This one, the elevation this one, and further elevation this one. It is PZ component. This one. So A2 sine theta 2 is this one, and A2 sine of theta 2 plus theta 3 is this one. So overall it is PZ. If you take this one is theta 2, then this is A2. So this one is A2 sine theta 2, and this one makes theta 2 plus theta 3 with horizontal. So this vertical advancement is A3 sine of theta 2 plus theta 3. So A2 sine theta 2 plus A3 sine of theta 2 plus theta 3 is PZ, equation number 1. And this one, what is R square? This one R square. So R square is D1 square plus this one. So this one is X component. This is theta 2. So A2 cos theta 2 is this one. This one. The projection of this. And A3 cos of theta 2 plus theta 3 is this one. So it is X component by taking X component. So D1 square plus this one. It is not A2. It is A2 cos theta 2. From this to this projection. And this is A3 cos of theta 2 plus theta 3. So D1 square plus this square is R square, equation number 2. So squaring and adding, this one is already square. So this one is square, taking square both the sides. PZ square plus R square equal to this square plus this square. This one addition. So A2 square sin square theta 2 plus A3 square sin square theta 2 plus theta 3. The middle term I have written here 2A2 A3 sin theta 2 sin of theta 2 plus theta 3. And for this A2 square cos square theta 2 plus A3 square cos square theta of theta 2 plus theta 3 plus D1 square, here I have put here D1 square, and for this middle term is 2A2 A3 cos theta 2 cos of theta 2 plus theta 3. So this one, this equation, and after squaring this equation we are adding these two. So PZ square plus R square. What is PZ square? So square of this A plus B whole square, applying formula. So A2 square sin square theta 2 plus A3 square sin square theta 2 plus theta 3. The middle term is here I have written 2A2 A3 sin theta 2 sin of theta 2 plus theta 3. And plus this R square. R square is what? D1 square plus this square. So A2 square cos square theta 2 plus A3 square cos square theta 2 plus theta 3 plus middle term I have written here 2A2 A3 cos of theta 2 into cos of theta 2 plus theta 3. Taking A2 square common, sin square theta 2 plus cos square theta 2 is 1. So PZ square plus R square. And these two terms as a whole, A2 square, these two terms common. So fundamentality is 1. So A3 square plus D1 square plus these two, taking common 2A2 A3 cos theta 2 cos of theta 2 plus theta 3 plus sin theta 2 sin of theta 2 plus theta 3. So PZ square plus R square minus D1 square minus A2 square minus A3 square is 2A2 A3 into this. We know the trigonometric identity cos alpha cos beta plus sin alpha sin beta is cos of alpha minus beta. So this one cos of theta 2 minus theta 3. So cos of minus theta 3, but cos is an even function. So cos of minus theta is cos theta. So this is cos theta 3. We have applied the trigonometric identity. So this one cos theta 3, subjecting cos theta 3, we have R square minus D1 square plus PZ square minus A2 square minus A3 square. But R square is Px square plus Py square. The projection here, this point in xy plane, coordinates Px, comma Py, comma 0. So this one is Px square plus this one is D1 square plus this one square is R square. So this one is Px, this R square is Px square plus Py square from the geometry. So R square is replaced by Px square plus Py square plus Pz square minus D1 square minus A2 square minus A3 square upon 2A2 A3. Suppose this term, this number is denoted as D. So using D defined above theta 3, above theta 3 is given by theta 3 is this one, it is d, so we can write d by 1, but cos theta 3 is d by 1, so theta 3, I have made mistake just theta 3 is adjacent side d by 1, sorry, d by 1 here, and this one is root of 1 minus d square. So tan theta 3 is what? Root of 1 minus d square by d. But there are two solutions in opposite quadrant also. So theta 3 is given by a tan 2. 2 is not multiplied, I am again repeating. Because of the common tan inverse function has domain open interval minus pi by 2 plus pi by 2, but this includes only two quadrant, this one and this one. But here in modern robotics we require all the four quadrant, so we have modified the domain minus pi to plus pi, this one. So this modified function is denoted as arc tan 2, second one, so it is not multiplied. So arc tan 2, that is a type of inverse, plus or minus root 1 minus d square d. So for this 3D arm, there are four possible solutions. I am giving demo. The first initial frame is this way. This is offset d1. This one is link length a2, and this one is link length a3. Initially home frame is here. This one is x, this one is y, and we want to achieve this point. It is in this, at a distance of something pz unit. So first we will rotate, because we require this line and this point coincide the same vertical plane. So if we rotate here this way, but the point is not here, point is here something. So it is rotated by theta 1, and then after it is theta 2 this way, and then after theta 3 with this link length it is theta 3 angle. So from horizontal it is theta 2 plus theta 3. So we can achieve this point, but this is elbow up, and this point achieve we can achieve this way also, elbow down. So there are two possible solutions here, elbow up, elbow down. And if we rotate this frame, this one, and then after this one, again here elbow up, elbow down. So there are four possible solutions. Sorry, this one is rotated this way, this way, and then after for elbow up, elbow down. So here there are two possible solutions. In this case also there are two possible solutions. So overall total four possible solutions. We have determined theta 1 and theta 3, theta 2 left. So see, this one is at an angle theta 2 from horizon, and this one is at an angle of theta 2 plus theta 3 with horizontal line, but from this wooden stick line it is theta 3 angle. So if you observe from this side, from opposite. So if you observe from this side, and if you put here, see, so this one, so this is A2, this one is A2, which is at an angle theta 2 with horizon, and this is A3. With horizontal it is making an theta 2 plus theta 3, but with this wooden stick line it is theta 3. We require this theta 2 left. We have obtained theta 1, theta 3, but theta 2 left. So this one is theta 2 we want to find. Suppose if you connect this point, end effector point, from here, this line. So suppose this one is angle theta, and suppose this angle, it with A2 theta dash. So theta minus theta dash is theta 2. Observe the figure. Theta minus theta dash is theta 2. So what is theta from the geometry of the figure? This one is whole angle theta. So considering this triangle, right angle triangle, and this one is from this line to this line, it is PZ. So tan theta, because of this is theta 2 and this is theta 3. This one. So this one is PZ. So this is PZ. So tan theta is PZ by root r square minus d1 square. And this theta dash. So if we connect this way and making right angle triangle here. So from this dotted line, it is an angle theta 3. So this one, this dotted line is A3 sine theta 3. So from this triangle, considering this right angle triangle, tan theta dash is this one line. It is nothing. Observe the figure. A3 sine theta 3. Opposite side, this one. Upon hypotenuse, this one. And this one is nothing but A2. This one A2. Sorry. Tan theta dash is opposite side upon adjacent side, not hypotenuse. And adjacent side is A2. This one is whole A2. And this dotted line is A3 cos theta 3. This one. So tan theta dash is opposite side A3 sin theta 3 upon A2 plus A3 cos theta 3. And theta 3 we have already obtained. So tan theta dash, so we have theta dash. So from geometry, theta 2 is theta minus theta dash. So theta 2 is arc tan 2, this one theta, that is arc tan 2 pz comma root r square minus d square. In notable symbol we can write this way, this one, and theta dash is this one, arc tan 2 theta dash is A3 S3 numerator upon denominator is A2 plus A3 C3. C3 stands for cos theta 3, S3 stands for sin theta 3. So theta 2 is theta minus theta dash. This one is theta. Sorry, this one is theta. And this one is theta dash. So theta 2 is theta, this one, pz comma, but r square is this one, r square, this one r square. This point is a coordinate px comma py comma 0. And this is the origin of our reference frame. So this one must be root of px square plus py square, which is r square. So r square is replaced by px square plus py square minus d1 square minus arc tan 2 a3 s3 a2 plus a3 c3. So if we have offset d1, link length a2 and link length a3, and home frame is this way, home frame is this way, origin is here, this way. So to achieve this point, we have no achievable point is px comma py comma pz. So they are known quantity. We want to achieve this. So inverse kinematics. So for this, first we have to rotate theta 1, and then after because it is not here, it is here. So then after theta 2 with horizontal line, and then after with wooden stick line, it is at theta 3. So the point is here, and the projection of this point is here. So this point has coordinate px comma py comma pz. So this is the one of the solution, but we have discussed already there are 4 possible solutions. Elbow for this, elbow up, elbow down, for this elbow up, elbow down. So there are 4 possible solutions. So this is the typical geometry of the 6R PUMA type arm, special arm, programmable universal manipulation arm, and this is the worldwide used. This arm is worldwide used. It's very known. Yes. We discussed the 4 solutions for a given point for PUMA type 6R PUMA type arm. So I told somewhat wrongly for solution, but now the precise solution this way. This is the home frame, and we want to achieve this point. Some in 3D plane. This is px, py, pz. So first we rotate this one, theta 1, then after theta 2, and then after theta 3. The projection is this px, py, 0. So this is one of the solution, elbow up, and this point actually we can this way also, elbow down. So this is the second solution. Now if we rotate this frame, but we want to achieve this point which is here, above, exactly above this here. So first we rotate this frame, whole frame, up to pi. This one, this way. So exactly here, this way, up to pi, this one, from this to this again, from this way, here it is rotated by pi, but we can rotate this way here, this one. Now pi plus theta 1, then exactly align with this, but the to achieve point is not here, it is here. So we have to further rotate alpha angle, and then we can achieve one elbow up, elbow down. See, this is the thing here. The another solution, theta 1 is pi plus this one. This is the original px, and plus this angle, arc tan to minus opposite sides, because of it is in second quadrant. So arc tan to minus root r square minus d1 square d1. Then we can achieve this point. So there are 4 solutions to achieve particular location. It is achievable point in workspace point in a workspace. And this one, see this, we have not shown here, we have taken reference frame, home frame here, so I have not drawn here. This is base. So the PUMA type arm like this. This is offset link, second link, and here some base, but I have not shown. I think I don't require for the geometry. So this way. So we have taken origin here, home frame here, so I have put here this one. Okay. See here, for particular rotation, it rotates about 320 degree. It is 250 degree. It is 270 degree. And the joint 4, 5 and 6. 4, 5 and 6. The wrist joint. So it can rotate this way, and this way. So there are 3 joints, but we have not shown here because of it is wrist just straight. So it is having length this much. Okay.